Welcome to the Civil Operations Demo. This is a collaboration between Microsoft and Bentley. This project showcases a powerful integration of Bentley's iTwin technology with Microsoft's Azure Digital Twins. And what this is a web app that allows us to view a roadway in Australia. It's called the Coffs Harbour Roadway, which is outside the town of Coffs Harbour. It's a 25-kilometer roadway, and we're going to hook it up to the Internet of Things and view live data of all the assets throughout that road. All right, let's take a look at our web app. You can see over here, there's a view of the Coffs Harbour town, and we need to look for our roadway. So in order to do that, we're going to turn up the transparency, and you can see right here the model that we're working with. So let's go ahead and take a closer look. We'll zoom in and rotate, and you can see that the roadway is made up of several different elements. So we have different asset types. As you can see to the left, we have bridges, tunnels, and roads. And all these assets have their individual sensors connected to them that help determine the overall health of that asset. For example, let's take a look at the bridge. You can see that it has this vibration and deflection sensor. Get one of the tunnels. You can see it's got a bunch of sensors. We have air quality, temperature, then we also have cameras in case there's some issue that arises, and we can hopefully get a view on site on what's going on in that tunnel. Then we have roadways. In the road segments, we have the vehicle counter that helps determine the congestion on the road. And again, we have a camera in case there are any issues that show up. Okay, so now that we have an understanding of the different sensor and assets, let's go ahead and turn on the live data. You'll see this pop up. What this means is we're signing in to get access to our ADT instance. Once you're logged in, you will see that the colors are changing for these assets. So you can already see the yellow and the green. What that is the overall health of that asset. Yellow means that it's getting worse. Green is perfectly healthy. And we can take a deeper dive. So let's click on, for example, this tunnel. You can see all the different sensors. And if you hover over one of the sensors, you can see the actual data, the latest data in the ADT instance that's stored, the CO and the NO2 values. And you can see they're changing too. So this is live data that we're currently streaming in from ADT. Let's give it a second, watch it change some values. You can see as the temperature goes yellow, the entire asset turns yellow. So it always picks out the worst case scenario based on all the different calculations values it's getting. Okay, so far you've only seen the green and the yellow, which are both acceptable values. That means there's no problem really, just fluctuating health of all these assets. So what happens when we actually have a situation? So let's simulate a crisis and see what that would look like. Oh, wow. So there it is, just in time, code red on T1SB. So when we click on that, let's see what's going on. You can see that the asset has turned red. That means we need to look into it like right now. And we have the sensor, the culprit sensor. You can see the CO values, they've gone about 2 to 3 times of what they were before. So this is a problem. And we have the camera. So maybe there's some hints that we can get on what might be going on here. So you click on that, click show image. And oh, wow, so there's an accident. And because of that, there's likely congestion in the tunnel. At this point, if I were the operator, I would either dial in, or hopefully this app has a feature in the future where I can turn up the ventilation for this tunnel and rescue the passengers from the crisis. So where does the data come from? This scary diagram shows everything you need to know about how the data flows. There are 2 types of data here. On the top is a live data that comes from the sensors, and the bottom is the iTwin model that includes the 3D geometry for the tunnels, bridges, and roads. Let's talk about that one first, since that's where we actually start. Infrastructure engineering data is often modeled using multiple applications. We can take these various formats and run them through what we call a bridge to transform them into a single cloud-ready iModel format. In this case, the data was originally modeled using our civil engineering applications, OpenBridge and OpenRoads Designer. Over here, you can see the bridge pushing the actual data from design files into an iModel on iModel Hub. If you don't know what the iModel Hub is, it's a cloud service for centralizing and managing infrastructure projects. Great, so once our data is on the hub, we can visualize it using an iTwin viewer. This viewer allows us to enrich the model with data from other sources, such as Bentley's Reality Data Service, Microsoft's Bing Maps, and even Azure Digital Twin. And that's exactly what we did for our demo. We customized this viewer to add those data connections and change asset colors based on sensor data that was coming in. One last thing here, how do we connect the bottom data to the top data? We use a cloud agent that generates DTDL formatted data from the IM model, which is then used to create the instance of our Azure Digital Twin. Now that we have our IM model and ADT instance in place, we are ready to talk about where the live data comes from. The story starts all the way back in the simulation service on Azure. It has a bunch of different devices that you saw in the model, and it generates telemetry information for those devices. And the way we define them is we can define each individual sensor type. For example, this is the air sensor, air quality sensor. You can see the NO2 values and the CO value, and we have a minimum and maximum and a unit. And we're passing all those values out. And this is hooked up to the IoT hub, where we have a unique ID to identify each individual device that's listed in the IoT devices blade under our IoT Hub instance. This is then hooked up to an Azure function, which takes in all this telemetry information and computes the overall health of a higher level asset, such as a tunnel. And you can see that happening live right here. So these are the values, and this is the values being written. And finally, while this function writes in all this information, this is hooked up to an instance of the time series data, and that gives us the historic values of everything that goes on within our model. So for example, I captured the same event here where we had the crisis. You can see this is the air quality sensor, and you can see the value of it spike up, and you can see the health of the tunnel 1, and see the value spike up as well as it goes out of bounds above 100 is when we see the red and we are in trouble. And that's what we started with in our model. So that's the story of how the data goes all the way from our simulation service into our app in real time.